Good day, everyone. In this video, I'm going to discuss how to find the domain and the range of the function. I will first define the domain and the range of the function. I will then give an illustration and examples will then follow. Lastly, the graph will be shown in every example to locate the domain and the range of the given function. So let's start. Now, the domain of the function is a set of values for which the function is always defined. However, the range of the function is the set of all values of the dependent variable corresponding to these domain values. Now, let's have here a mapping to illustrate the domain and the range of the given function. So we consider the function f from the set of real numbers to the set of real numbers. So let's have here the mapping. So this is our function f. So we have here point x here, and then this maps which is equal to f of x. Now take note here that x is the value for our domain R. So we have the domain R here. Then the codomain is our codomain still R, the set of real numbers. So X here is coming from our domain R. Then Y here is in our codomain R, which is part of our range, the Y. So X is the independent variable. Y is our dependent variable. So let's have an example here to really illustrate the concept. So let's have here a function f defined by f of x equals, say, 2x plus 1. So again, x is the, okay, here, I'll just put it here. X is our independent variable. And then y, for y, we have here dependent variable. Why is it called dependent? Because the value of y, the resulting y, will depend on the value assigned to x. So here, x is the independent variable because you can assign any value for x as long as it is part of our codomain. Here, rather part of our domain. Here, our domain is R. Therefore, our x is a real number. So you can assign any real number for x. This is our independent variable. Then our y depends on the value assigned to x. So for example, if we have here the function f of x equals 2x plus 1. Now, if x is equal, say for example, to 1, then f of x, by the way, y is equal to f of x, so we can have y, which is equal to f. Our x now is 1. Take note, x is 1, so we replace x by 1. So f of 1. Instead of f of x here in our defined function, we have f of 1. So we replace 1 to x here. So 2 times 1 plus 1. So y is 3. So notice that if we assign a value to x, a real number, we get the value of y, our dependent variable, which is 3. Now, if we assign another value, say for example, -2 to x, since this is also a real number, so y Say, let's have here y sub 1, this is y sub 2. So y sub 2, or this is f of our x is negative 2, so we replace negative 2 to x. So from our defined function, we have here 2 times x, which is equal to negative 2 plus 1 is equal to, we have negative 4 plus 1 is negative 3. So if we assign another value here for x, say x equals 0. So say we name it as y sub 3. So we have f of 0 is equal to 2, excuse me, 2 times 0 plus 1. So 2 times 0, what's happening? Again, yung delete. Ay, nakip man din. 2, again. So again, since x sub 0, oh, rather, x equals, again, since we assigned the value for x, which is 0, so our defined function becomes f of 0 equals 2 times 0 plus 1, which is equal to 1. Now, as you noticed here, if we assign any values to our x, real number, x, notice here that the value of our y, the value of the y changes. So when x is 1, our y is 3. When x is negative 2, our y is negative 3. When x is 0, our y is 1. So notice that we assigned any values to x. And the values of our y depend on the values of our x. Hence, here, in our illustration, it's very clear that x is the independent variable, and then y is our dependent variable. So the value, the resulting y depends on the assigned value to x. Okay? So now, for the domain of the function. So take note here, in our definition, the domain of the function is a set of values for which the function is always defined. Now here, set of values. Now, if you're going to assign any values, any real numbers to x, is the function defined? Take note that the function is defined by this. So we have here, consider the function f. So let me add here, defined by this one. So defined by this one. Okay. So if we're going to substitute a value, any real number to x, this is always defined, as you can see here. So if we're going to, what's this? Assign any value to x, any real number, this is always defined, right? So our domain D, let's try to denote the domain as D, is the set of values of x such that, this is the notation for such that, x is a real number. So we mean this one, x belongs to the set of real numbers, or simply x is a real number. So the set of real numbers is the domain of the given function, this case. Now for our range here is a subset of our codomain, wherein it is denoted by, here in our illustration, we have the set of values of y, which is equal to f of x. So it is a function associated with x. So it means the range is the set of all images. Take note here that x is part of the domain. If we map this one, y is the image of x, right? Y is the image of x. So here, this one here, the smaller set here of our codomain is the set of all images of our function. So images of x. Hence, this is our range. So by the way, the range could be equal to the codomain if all the elements here have three images. So, or the function becomes onto. If the function is onto, the range, the set of all images, is equal to the codomain. So that's it. Therefore, the range here, let us denote it by R for the range. It is the set of values of y, values of y here. Now, as you can see in our defined function here, whenever we assign a value, a real number to x, our function or domain, or our function is always defined. So since our domain is R here, the set of real numbers, if you're going to assign, it's like here, oh, we have assigned here, the answer is 3, -3, 1, and many more. So there are an infinite values of y here when we assign any real number to x. And those values are all real numbers. If we assign a real number here, the resulting is a real number. So if we assign any real number here, the resulting is any real number. Hence here, our range is the set of all y's, of all the values of y, where y is a real number. Hello? So here, we denote the domain with the set of values of x. So as you will notice later on, I use x as the value, or x with the value, or represents the value, or the member of the domain, or element of the domain. And then y is for the range. So to illustrate more the concept, let me have this, another function defined by g of x equals the square root of x minus 2. Now, this is the graph of the given function. So to illustrate well the range and the domain of the function, I use here the graph. So to locate where is the domain of the function and the range of the function using the graph of the given function. Now for this function here, the graph looks like this. So this is the graph of the given function. So as you noticed here, we have here the green. The green color is our graph of the function. Now, for the domain T, we have this one, the horizontal line. domain D. So we will be looking at the values of our X. So it is here. This will be the domain. Here, the domain of the function is somewhere located here in the horizontal line, the x-axis. So we will try to locate it. Okay, so here, if this is the point of the graph, the value of x here is 2. So this is the value of x. When we have a point here in the graph, the value of x, or the member of this point here in the graph, this one, so the value of our x is here. And then if we have this point, the value of x is here. If we have this point, the value of x is here. Then we have here, then here. As you notice here, the values of x runs from 2 going to infinity. Follow? So for the values of, for the points in the curve, if you're going to get the values of x, it starts from 0 to 2 to infinity. So here is the domain of the function. So following the curve of the line and then finding the domain of the function. So it starts from 2 to infinity. Number, so you can have this one such that x, as we observed here, x is greater than or equal to 2. Follow? Now let's proceed to the range of the function. We denote it by R. So the range of the function is the set of values of y. Y, right? So y for dependent variables. So somewhere here in our vertical line here. So let's try to check using our graph. So of course, we will be basing the values of y based from our curve here, from our graph. Now, if we have here the point here, the values of y is here. So point on the graph, then the values of y is here. Another one, if we have this point, the values of y is here. If we have this point, the values of y is here. Now notice that the values of our y, which is part of our range, starts from 0, right? If we have this point here, the value of y is 0. And if we locate it, some of the points on the graph, it starts from 0 going to infinity. So take note, because our graph will extend, so I put line. So because it extends here, the values of our y starts, the value of our y starts from 0 to infinity. Here, hence the range. Therefore, we have this one. The derivative is what? 0. Okay, the set of all y, which is a real number, such that y is greater than or equal to values of y, such that y is greater than or equal to do not the function. Now let's have example number 1. So we are going to find the domain and the range of the function f defined by f of x is equal to 2x plus 1. So actually, the domain of this is the set of real numbers. Why? Why is the domain the set of real numbers? We have this one, set of x, because any assignment of x here, any assignment of x, the function is always defined. So here, if you assign any value to x, still we can get f of x. Still, f of x is defined. Hence, the domain is the set of all real numbers. I discussed this a while ago. So the range here is the set of the values of y such that y is a real number. So again, as what I have said a while ago, set of y is the value of y is the value of our f of x, which is equal to 2x plus 1. So whenever we substitute or we assign value to x here, any real number, the value of y is also a real number. So if we assign any real number to x, the value of y or the value of y changes, but still a real number. Hence here, R is the set of the values of y such that y is a real number. And the range. Okay, as you can see here, so they have said a while ago, the domain of the function or the members of the domain of the function are located here in the horizontal line. Now, if we are going to get any points on the line, say this point, this is the domain. We have this point, this is the domain. This point, we have here the domain. And this point, we have, oh, sorry. So in this point, we have, this is the domain here, here, here. And then in this point on the graph, we have here the domain. Here, if we have this point, the domain is here. This point, the value of x is this one. Then this point, the value of x is this one. So as you can see, the values of the domain are located here. So as you can see, if we have this one, we have here the value of x. So hence, the domain is the set of real numbers. Then for the range, if we have this point here, this is the range. In this point on the line, we have here our range. If we have this point, our range is this one. If this point, this one is our part of the range. So this one, this is y. Here, the value of y is here, here. Then if we have here, then this is our y. So here, so this is our y. Hence, the range is the set, or as you can see, cover siya. So it is the set of real numbers. The y is the set of real numbers. So that is our range, the set of real numbers. Okay, now let's proceed to example number 2. Now we are going to find the domain and the range of the function g defined by g of x, which is equal to 2x plus square root of 3x minus 6. So we are going here to find the domain of the function. So the values of x. So we start first for the values of x for our domain. Now take note from our definition of the domain. It is the set of values to which the function is defined. So values of x. And it will make the function defined. Notice here, for the definition of our function, 2x, for 2x here, any value of x will do. So this is now okay. However, in our square root here, we have a restriction because we cannot get the square root of negative number, right? In the set, under the set of real numbers. Now, if you are going to try it in your calculator, the square root of a negative number is error there. So it means the function is undefined when the number inside the radical square root is negative. So let's try to, what's this? Divide it to the values of x where the function is defined or not. Now again, it's what I have said a while ago. When the value of the number here inside the radical sign is negative, it means g, which is the function, is not defined or undefined. Undefined siya. Follow? Undefined in R. Because we cannot get the square root of a negative number. And if we have the square root of positive means 0 is included, it means that g is now defined. So g is defined. Now, here, when we talk about domain, it is the set of values where the function is defined. So we will focus on the values of x where our function g is defined. So we will not be focusing here, the first one, the negative inside, but we will be focusing here because we will be focusing on the values of x to in which our function is defined. Now take note here. So let's have this one. When the value inside is positive, now take note the expression inside is 3x minus 6, right? So expression inside is positive. Can you follow? I'm sorry, this is positive. So I have written here positive inside. It means this 3x minus 6 is positive. So positive. So that's why I have written here 3x minus 6 is positive. Now, when we say positive, it means if 3x minus 6 is positive, it means 3x minus 6 is greater than or equal to 0. Okay? Now, in this case, we have here this inequality. So our goal here is to find the domain of the function x. So we will be solving for x here. So by using algebraic concepts, we will manipulate this one. This is, okay, greater than or equal to, we move negative 6 to the other side, and then it becomes positive 6. And then we just copy the symbol greater than or equal. Then we divide both sides by 3. So we have here x divided by 3x divided by 3 is x. Copy the symbol. 6 divided by 3 is 2. So we have here x is greater than 2. So when x is greater than or equal to 2, our function is defined. Hence, this is part of our domain. So the domain is equal to the set of values of x. So x here is a real number, so you can put it here, such that x is greater than or equal to 2. So as simple as that. So that's our domain. Now to find the range of the function, of course, you can do it manually. Actually, there are many ways on how to find the range of the function. So in my way here, I use the generic way. So to find the range of the function, you can substitute the values. That is the most used way. So you're going to substitute the values of the domain or x and then observe for the pattern. That is the most generic way. So you will be observing pattern. But then sometimes it's very difficult to observe patterns sometimes. So we will be using another way. So you will analyze the given function and so on. So first here, let's try to substitute because our x is greater than or equal to 2. So we will be focusing on this because our y, katong range here, the set of values of our range, we have y, right? So y depends on the value of x because x here is greater than or equal to 2. So we will start first on the value of 2. So for the value of 2, what is our g of x? Say we have here y sub 1 is equal to g of, we have 2 here, we replace 2 here to x. 2 is equal to what? We just replace 2 here. So 2 times 2 plus square root of 3 times 2 minus 6. This is, we have 4 plus, this is 6 minus 6 is 0 and square root of 0 is 0. So it is equal to 4. Then next is we can have, say 2, next to 2 is 3. So let's have this as y sub 2. So this becomes g of 3 equals 2 times 3 plus square root of 3 times 3 minus 6, which is equal to 6 plus, what's this? So this one, square root is 9 minus 6 is square root of 3. And we know that square root of 3 is greater than 0. So it is obvious that this is greater than 6 rather. So greater than 6, right? Okay, 6 plus the square root of 3 is 1 point something. Okay, so greater than 6. So as you can see, as we substitute the value of our x from 2 and number greater than 2, the values of our y are greater than 4, greater than or equal to 4. So it starts from 4 going up. Okay, therefore, the range of the function can be expressed as here y in R, such that y is of course greater than or equal to 4. So we can write it that way. Or another way to find the domain here, or another way we will analyze our given function, defined function. So we have here the defined function 2x plus square root of 3x minus 6. This is our given function. Now take note here, because x starts from 2, because x is greater than or equal to 2, so we can substitute here x by 2. So it is greater than or equal. Follow? Because we substituted x by greater than or equal to 2, so we can replace equality here by greater than or equal to 2 times 2. Plus, we know that square root of 3x minus 6 is greater than or equal to 0, right? So, by the way, this is minus. Greater than or equal to 0, because if you are going to get the square root of any number, the answer is greater than or equal to 0 always. So, because what is inside here is positive man inside. So, 0, square root of 0 is 0, square root of 1 is greater than 0, and so on. So, take note here, because this is greater than or equal to 0, therefore, if you replace here 0, we have here 2 times 2 plus 0, greater than, this is greater than or equal to 0. So we have here, this is equal to 4. So it means here that y, which is equal to g of x, so here, it means y, which is equal to g of x, this one, is greater than or equal to this one, 4. So that's why we have here y is greater than or equal to 4. So it's up to you if what method do you want to use. If this method, substituting the values of x and then find the values of y and then observe some patterns, or here, or this one. Or you can use the graph later on. I will be showing to you the graph of the given function, and then we will locate the domain or the range. So it's up to you, as long as you can find the domain and the range of the function. So let's have here the graph of the function. So actually, this is the graph of the function. I'm using here GeoGebra application. So we have here if this is the point on the function, let's try to locate first the domain. This is the point of the function, the domain or the value of x is here. This is our x is here. Then we have here. So as you notice here, the value of x starts from infinity. Hence, the domain of the graph is the set of values of x in R such that x is greater than or equal to 2. Follow? And then for the range of the function, of course, the graph of the function starts here. So we will start here, locating the point. So this is the value of our y. So by the way, we have x here, then on the vertical line, we have y. So if we have here the point on the curve, we have the value of y here. So if we have here, the value of y is here, here, the value of y is here. So as you noticed, our range, the value, the elements in the range will start from 4 going up. So 4 to positive infinity. We have here. Okay, so here. Sorry. So 4 to positive infinity. Hence, the range of the function is equal to the set of values of y, real number y, such that y is, as you can see in our graph, greater than or equal to 4. So that's it. As you have noticed, we have the same result here in this method. So that's it. Now, let's proceed to example number 3. Now, we are going to find the domain and the range of the function h defined by h of x equals a fraction. We have 2x over x plus 3. So to do it, we will be using the generic way first. And then after that one, we will use the graphical method. So first, because we will be looking on the domain of the function, we will be classifying the values of x to which the function is defined or not. Now take note, if we are working on fraction, here, since fraction man siya, so if we are working on fraction, by the way, when is the fraction undefined? So that's the question. When is the fraction defined? So, or when is the function undefined? Fraction rather. When is the fraction undefined? Now take note that if you have here, if the denominator is 0, that will make the fraction undefined, right? If we have, say for example, 5 over 0, of course, if you solve that using your calculator, it is error, right? So this is undefined. If the denominator is 0. So in this case, let's have this one. If x, our denominator, plus 3 is equal to 0, this means that 2x over 0, right? When x plus 3 is 0, we have 2x over 0. This is undefined. Here, h, the function h, is undefined. However, if x plus 3 is not equal to 0, the other way of this, we mean 2 of x plus 3, which is not 0, means h is defined here. Follow? Now, again, for the domain, we are looking for the values of x where the function h is defined. Therefore, we will not consider this one, rather, we will consider this when x plus 3 is not equal to 0. So let's solve this, solve for x to find the domain. So of course, we move 3 on the other side and then copy the not equal. This becomes negative 3. Follow? So here, you move this to the other side, we have -3, then not equal. Therefore, when x is not equal to -3, our function h is defined. Follow? Not equal to -3. Hence, the domain is the set of the values of x in R such that x is not equal to -3. Can you follow? Notice that when x is -3, of course, this becomes 0. So h is undefined when x plus 3 equals 0. So when x is not equal to -3, so we can now have the domain of the function. Now let's proceed to the range of the function. So again, for the range of the function, you can assign the values of x here to our function h of x, which is equal to 2x plus x, 2x over x plus 3. So you can assign values as many as you can, as long as you can observe pattern. After observing the pattern, then you can write your answer. However, sometimes the pattern is not really, what's this? Clear. So it's not really clear. So you need to use another way to find the range. Now, here is the other way in finding the range of the function. So we are going to solve for x in terms of y. So solve for x in terms of y here. So we will solve for x from this one. So we will let y be equal to h of x, which is equal to 2x over x plus 3. So we will use y here equals 2x over x plus 3. So we will be solving for x here in terms of y. So we use the cross multiplication. So we have here y times the sum of, the sum of x plus 3 of here equals, of course, 2x. Okay. So again, if we use cross multiplication, it is understood to have 1 in the denominator. So we multiply that 1 equals, we multiply that 1. So y times this, we have this one. 1 times 2x, we have this one. So we distribute this one, y times x is xy or yx. And then here, y3 plus y3 or 3y. Then copy here. Then next, we move x here and then move term having y there on the right side, okay? Because we are going to solve for x. So retain term having x here, then move this one on the other side, so this becomes 2 negative 2x equals, we will move this one to the other side, to the right side, this becomes negative 3y. So factor out x. So x times, if we factor out x, what is left here in our first term, we have y, minus, we factored out x here, what is left is 2. So this is negative 3y. And then we will solve for x, therefore we divide both sides by y minus 2. Divide both sides by y minus 2. Therefore, we have, okay, this is cancel. So what is left? We have x equals negative 3y over y minus 2. So again, I will write it here. So I will write it here. We have here, wait lang. Let me erase this. So I will write it here to make it go on clear. So we have here x is equal to negative 3y over y minus 2. So we have solved here value of x in terms of y. So to find the range, we will be using the same concept here in our domain. we will be looking at the values of y to which the function is defined. So here, so let me have an arrow here. When y, well, let's focus on the denominator because we have here fraction. Because when the denominator is 0, our function is undefined. So when y minus 2 is equal to 0, then we have here negative 3. So let me have this one. Negative 3y over 0, right? And we know that this is undefined. Now, if y minus 2 is not equal to 0, we mean negative 3y over y minus 2 is defined. So we will not focus on this one, rather we will focus on this. Hence, if we are going to solve this one, we have y is not equal to 2. Follow? Here from y minus 2 not equal to 0, you're going to move negative 2 to the other side, it becomes positive 2, and copy not equal symbol. So therefore, y is not equal to 2 will make this expression defined. Hence, our range is equal to the set of the values of y in R such that y is not equal to 2. So we have determined already, we have found already the domain and the range of the function. Hello? So we have here the domain, this one, and we have the range. So let's try to have another way of finding the range and the domain of the function. So let's have this one. So again, the same event. So the graph of this function here, h, defined by this, is the green curve. So actually, we have here the line, an asymptote line. So asymptote line means the values or the line here in the curve will not touch to the asymptotic line here. So the red broken line is our asymptote. So it will not touch. Oh, as you can see, the curve is not touching the line. And the same thing here, the curves are not touching the line. So it means the value here is the function, our function is undefined or not defined with the value here, this one, here and here. So take note, for our range, we have the values on the horizontal range, rather domain, the values are on the horizontal line. So take note, our graph or curve is not touching the broken red line. So if you're going to locate, so for example, we have this point, so x is 0. Let's start first on the domain. If you have this point, it's 2. This point for this. So from here, we have found that the domain, this is included in the domain. Now, we have still the graph here. So let's have here the point. This is our x. The point, this is our x. Here, if this is the point, this is our x. As you can see, the graph is not touching this point here. This is negative 3. The graph is not touching negative 3. So we put a hollow circle here. So hollow, it means it is not included in our domain. Because as you can see, the graph is not touching. So we have no values of x there. So our x is this one, the domain. So it will not touch -3. -3 is not included. And the same thing here. If we have the point here, the value of x is here. We have point here, the value of x is here. Here, we have here, here, then here, and so on. And then here, it will not touch -3. So you can see the graph, the curve rather, the curve here is not touching the point -3. So we have here. Therefore, the range, the domain of the function, this is included in the domain of the function except -3. Hence, the domain is the set of all the values of L to -3. Hello? Not equal to -3. So the same for our range. So the same idea to find the range. So we will be focusing on the y-axis. So for the y-axis, we have here y-axis. So if we have the point here, this is our value of y. Here, if we have the point, value of y, this one. So from point here, we have here the value of y. Here, value of y. Here. So notice that the graph doesn't touch the point y equals 2. So here in this case, it is hollow here. This one, hollow. Let's have here, hollow. So it will not touch. If we have here the point, as you can see, it will not touch +2. So from here, +2 to +2 is not included. The range of the function will include this one, points. Okay, so let's have the other curve here. If we have the point here, the value of our y is here. Point here, this is our y, and it will not touch 2, right? Y equals 2. If we have our point here on the graph, we have this value of y. We have here value of y. If we have here value of y. As you notice, it starts here going down to -infinity. Now, as you observe, we have shaded the line here, except when y is equal to 2. Hello? Therefore, the range here is the set of the values of y in R such that y is not equal to, number here is 2. So that's how to find the range of the function using the graph of the function. So we have derived a while ago using other method. Another method that the domain is this one, and the range. You have the same answer in any method you will use. So I hope it is very clear to you now on how to find the domain and the range of the function. Actually, there are many ways on how to find the domain and the range of the function. It's up to your preference to what method do you want to use. So you can use graphical method if the graph is available or you know how to graph it, or you can use the other method. So that's all. Thank you for watching and listening. Goodbye, everyone. God bless.